Just like the graph of sine and the graph of cosine, the graph of tangent is also periodic. That is, it repeats itself after a certain interval period. Now, this is the graph of y equals tan theta. Here, I drew the graph in the range theta is greater than or equal to minus 90 degrees but less than or equal to 360 degrees. Now, as I said earlier, the graph of tangent repeats itself after a certain interval period. So, if we look at our graph, we can see this graph repeats itself every 180 degrees period. So, I'll use this arrow to show it here. As you can see, the graph y equals tan theta crosses the x-axis, in this case theta, at 3 points in this given range of angles. So, here are the 3 points. Since this is the graph of y equals tan theta, we could say tan theta equals 0 when theta equals 0 degrees, 180 degrees and 360 degrees. Remember, there are more values for theta, but here I only show the values for the range theta is greater than or equal to minus 90 degrees but less than or equal to 360 degrees. Now, this graph has no maximum or minimum value. The graph y equals tan theta has vertical asymptotes at theta equals minus 90 degrees, theta equals 90 degrees and at theta equals 270 degrees in the range theta is greater than or equal to minus 90 degrees but less than or equal to 360 degrees. So, this is why the graph y equals tan theta does not have maximum or minimum points but approaches positive or negative infinity as the curve approaches the asymptotes at minus 90 degrees, 90 degrees and at 270 degrees. So, the common factors of the graph y equals tan theta is that it repeats itself every 180 degrees period and crosses the x-axis at minus 180 degrees, 0 degrees, 180 degrees, 360 degrees and it goes on like this depending on the range of angles we draw the graph in. And another common factor is that the graph of y equals tan theta has no maximum or minimum value. And also, it has vertical asymptotes at x equals minus 90 degrees, x equals 90 degrees, x equals 270 degrees and it goes on like this depending on the range of angles we draw the graph in. Now, let's take this example. Sketch the graph of y equals tan x in the interval x is greater than or equal to 0 degrees but less than or equal to 360 degrees. Now, this is the graph of y equals tan x in this given range of angles. So, the graph crosses the x-axis at 3 points at the coordinates 0 degrees, 0, 180 degrees, 0 and at 360 degrees, 0. So, the graph crosses the x-axis when y equals 0. We could say tan x equals 0 when x equals 0 degrees, 180 degrees and 360 degrees. The graph of y equals tan x has no maximum or minimum values and has vertical asymptotes at x equals 90 degrees and at x equals 270 degrees. Now, as I said in my 2 previous Pure Maths videos, we can apply transformations to trigonometric graphs just like any other graph. So, I've already covered about transforming graphs in my previous Pure Maths videos, so if you want, check them out for more details. Now, let's take a look at a few examples. Apply the following transformations to the graph of y equals tan x in the interval x is greater than or equal to 0 degrees but less than or equal to 360 degrees. So now this is the graph of y equals tan x in the interval x is greater than or equal to 0 degrees but less than or equal to 360 degrees. Y equals tan 2x. This is the stretch of the graph y equals tan x by a scale factor of 1 over 2 in the x direction. So all the x coordinates are held and hence this is the graph of y equals tan 2x. The graph y equals tan 2x crosses the x-axis at 5 points at the coordinates 0 degrees, 0, 90 degrees, 0, 180 degrees, 0, 270 degrees, 0 and at 360 degrees, 0. And also has 4 vertical asymptotes at x equals 45 degrees, x equals 135 degrees, x equals 225 degrees and at x equals 315 degrees. The graph y equals tan x had a period of 180 degrees, that is it repeated itself every 180 degrees period. Now, since all the x coordinates are held, the graph y equals tan 2x has a period of 90 degrees. Y equals tan x plus 45 degrees. This is the translation of the graph y equals tan x by 45 degrees in the direction of the negative x-axis. So, we subtract 45 degrees from all the x coordinates and hence this is the graph of y equals tan x plus 45 degrees. So, the graph now crosses the x-axis at 2 points at the coordinates 135 degrees, 0 and at 315 degrees, 0. And also, the graph now has 2 vertical asymptotes at x equals 45 degrees and at x equals 225 degrees. So, the graph y equals tan x plus 45 degrees crosses the y-axis when x equals 0. So, when x equals 0, y equals tan 45 degrees, y equals 1. And hence, the graph crosses the y-axis at 0 degrees, 1. y equals tan x minus 45 degrees. This is the translation of the graph y equals tan x by 45 degrees in the direction of the positive x-axis. So, we add 45 degrees to all the x coordinates and hence this is the graph of y equals tan x minus 45 degrees. The graph now crosses the x-axis at the coordinates 45 degrees, 0 and at 225 degrees, 0 and has two vertical asymptotes at x equals 135 degrees and at x equals 315 degrees. The graph crosses the y-axis when x equals 0, so when x equals 0, y equals tan minus 45 degrees, y equals minus 1. And hence the graph y equals tan x minus 45 degrees crosses the y-axis at 0 degrees, minus 1. Now let's take a look at a few more examples. Apply the following transformations to the graph of y equals tan x in the interval x is greater than or equal to minus 180 degrees but less than or equal to 180 degrees. So now this is the graph of y equals tan x in this given range of angles. Y equals minus tan x. This is the reflection of the graph y equals tan x in the x-axis. So now this is the graph of y equals minus tan x. The graph now crosses the x-axis at minus 180 degrees, 0 degrees and at 180 degrees and has two vertical asymptotes at x equals minus 90 degrees and x equals 90 degrees just like the original y equals tan x graph. Y equals tan minus x. This is the reflection of the graph y equals tan x in the y-axis. And hence this is the graph of y equals tan minus x. The graph still crosses the x-axis at minus 180 degrees, 0 degrees and at 180 degrees just like the original y equals tan x graph. The graph y equals tan minus x has two vertical asymptotes at x equals minus 90 degrees and at x equals 90 degrees.